Swayam Prabha. Digital India. Educated India.
Welcome to this course on time series modeling and forecasting. This is the first lecture of the course. So, before starting the course, let me introduce myself. My name is Anup Chaturvedi. I was professor in the Department of Statistics, University of Allahabad. And then just 2 years back in 2019, I got superannuated from the department. So, this course on time series modeling and forecasting is of 40 hours. In this course, I will try to cover most of the topics of time series analysis, and actually I will try to cover most of the topics which are taught at UG and PG level in different Indian universities, and then I will cover some advanced level topics also. A brief outline of the course I will give you towards the end of this lecture. Then why we need time series analysis, or why we need this course, and for whom this course has been targeted. You know, statistics is the science of data. You want to extract information from the data. And there are several statistical tools which are used in various fields. Just look at any field, you find people applying different statistical tools, because ultimately in every field you get data and often you have to draw inferences, you have to draw some decisions or some conclusions, some inferences based on the data, or you can say you want to extract information from the data. You take any field, everywhere you find people applying statistical tools. The problem is that often the applied workers apply the tools without having enough background of the theory behind it. Then sometimes unknowingly they apply some wrong tool to wrong data set. For example, if you apply the classical inference procedures to time series data, then obviously it is not going to give you proper results. So, that is why at least some theoretical knowledge of the tools which you are applying, or the statistical tools which you are applying, is must even for the applied workers also. Now, during the last few decades, particularly after the emergence of computers, the direction of data analysis, the direction of statistics has entirely changed. Earlier, it was not possible to store large data set. it was not possible for the people to do very high level computing. But with the emergence of computers, now it is possible to store big data set, to analyze the data very fast. You do not require much time to analyze even big data set. So, the direction of data analysis or the statistics has entirely changed. Similarly, the direction of time series analysis has also changed. Earlier, people were using a classical approach for analyzing the time series. Then, after the book of Box and Jenkins, people started using Box-Jenkins approach based on some linear time series models like autoregressive model, moving average model. Then people started working on more complicated models. Say if your time series is non-stationary, then people use some integrated models, or if your time series has long memory, then people started using some fractionally integrated models. So, there are many modifications in the time series theory also, particularly after the emergence of this Box-Jenkins approach. Then earlier it was not possible for people to analyze the time series given the limited computing resources. Now, not only the fast computers are available, but several statistical softwares are also available, which one can use for analyzing the time series. So, now it is not difficult to apply different time series tools to real data set, even if you have very big time series. So, the objective of this course is to cover most of the theoretical aspects of the time series. Now, let us come to this small example. Suppose you have two sequences of observations. So, many of you must have seen this roulette game, which is played in different casinos. So, in roulette game you have a big wheel, and then there are several numbers written on the roulette wheel, and then they roll the wheel and you bet on a particular number, and if the roulette wheel stops at that number, then you win. Now, in that roulette wheel, suppose you have 100 observations, y 1, y 2, 100, y 100. So, you have these 100 observations, and these are the outcomes of 100 rounds. On the other hand, suppose you have 100 observations, y 1, y 2, y 100 on the closing prices of a stock for 100 consecutive days. Now, what is the difference between the nature of outcomes of these two experiments? The basic difference is, in the case of first set of data, different observations are independent of each other. Means the if you have some idea of say first 50 observations, if you know the first 50 observations, then you will not be able to predict the 51st observation. These 50 observations do not have any information about the 51st observation. And the reason is very simple. Different observations are independent of each other. On the other hand, in case of stock price data, the stock price of today may give you some idea of the stock price of tomorrow, or if you have information or data on stock price of say last 50 days, then by looking at the movement of the stock prices, you can say something about, you can have some idea of the stock price of next period. So, it may be possible for you to predict the stock price of next period. And the reason is very simple. Different observations are not independent of each other. There is some kind of correlation or some dependence in different observations. Now, the same difference exists between the usual sample which you have, the identically independently distributed observations which you have, and the time series data. In the classical inference procedures, we assume that the independent observations are obtained under identical conditions, means your observations are identically and independently distributed. For example, if you are applying t-test, then you need identically independently distributed observations. Or even for applying some estimation procedures, say suppose you are applying maximum likelihood estimation procedure. If you have a random sample from the normal distribution, then you can apply maximum likelihood procedure. You can easily calculate the likelihood function, and then you can estimate the mean of the distribution, variance of the distribution easily. And the basic assumption behind your estimation procedure is the observations are identically independently distributed. Now, time series data are chronological sequence of observations recorded at specific time intervals, such as in hours or months or years, etc. Means you may have hourly data. You may have hourly data on temperature, or you may have hourly data on pollution level, or you may have monthly data, monthly sale of a departmental store, or you may have yearly data. So, you have a chronological sequence of observations, and then in time series data, the observations at adjacent points are not independent, they are dependent. Now, since different observations are dependent, it may not be possible for you to apply some classical inference procedures. You may not be able to apply t-test or f-test directly to your time series data, because then you require the assumption of IID observations, and time series data do not satisfy that assumption. Then if you want to apply maximum likelihood procedure, then your likelihood function may be complicated. So, it may not be so easy for you to apply maximum likelihood procedure for estimating some parameters of your model. So, the simple question is dependence of observations a curse or advantage? Some of you may think that, well, this is a big problem, you cannot apply classical inference procedures, so it is a curse. But then there is something advantageous also, and that is the dependence between different observations. In the previous example, in a casino, you won't be able to predict the next outcome of the game, and this is because the observations are identically independently distributed. On the other hand, you are able to predict the next time period's share price if you have the past observation, because different observations are dependent, different observations are correlated. So, the past observations have some information about the future, and then you can make use of that information for forecasting purpose. So, this is the advantage of time series observations. Now, this advantage you do not get when your observations are identically independently distributed. Now, your statistical analysis tools depend upon what kind of data you have. So, before applying any statistical tool, you must know what type of data you have collected or type of the data. So, we considered cross sectional and time series data. Cross sectional data have observations coming from different individuals or groups at a single point in time. Then samples are constructed by collecting data across a range of observational units, say people, objects, firms, etc. simultaneously. So, you have different individuals or different groups, and then you collect data at a single point of time from those individuals or from those groups, and then you get the sample. For example, closing prices of a group of 20 different tech stocks on 30th June 2021. So, on a particular date, you have considered 20 different tech stocks, and then you have taken observations on their closing prices. So, this data is a cross section data. Data on maximum temperature, humidity, wind speed of 13 coastal districts of Tamil Nadu on a particular day, say 31st July 2021. So, you have collected data on 3 variables: temperature, humidity and wind speed, and then you have collected data from 13 coastal districts of Tamil Nadu. So, these are your sampling units. From these units you have collected data on a particular day. So, this is cross sectional data. At a particular point of time you have taken data. Then stock returns earned by shareholders of Tata Consultancy Services (TCS), Infosys and Reliance Industries as for the year ended 31st December 2020. Again you have cross section data. So, you have data on 3 companies share prices, stock returns, and you have taken data on a particular fixed point of time. Now, this kind of cross sectional sample can describe the performance of returns at a particular point of time. But whether the stock returns of different companies are increasing or decreasing over time, you will not get this kind of information from this cross sectional data. Of course, you can compare the prices of or the stock returns of Tata Consultancy Services, Infosys and Reliance Industries for a particular time, means for the year ended on 31st December 2020, but you will not get this kind of information whether the stock returns are increasing or decreasing over time. So, this is the limitation of cross section data. Then you have time series data, set of observations collected at usually discrete and equally spaced time intervals. So, some of the examples are daily closing prices of TCS recorded over the last 6 months. So, now you have time series data, and on the basis of your data you can say that whether closing prices are increasing or decreasing, or what is the pattern of the closing prices of TCS share. Then weekly sale figures of coffee at a coffee shop during January to December 2020. So, a coffee shop is taking observations on its weekly sales, and the observations are from January to December 2020. So, it is a time series data. And in this time series data, different observations are not independent of each other. So, the past observations have some kind of information about the future observations. Or you have quarterly data on GDP of India during 1980 to 2020. On the basis of this quarterly data, you have time series data, and you can make the kind of inferences whether this quarterly GDP has some increasing pattern, or it has some decreasing pattern, or it has decreasing pattern up to a particular point of time and then increasing pattern, or vice versa. So, this kind of information you can get from the time series data on GDP. Then you have monthly data on number of cancer patients visiting a hospital during 2001 to 2020. Again, this is a time series data, and usually these observations are not independent of each other. The past observations have some information about the future observations, and on the basis of this data you can say that whether the number of cancer patients is increasing or decreasing. Or suppose you have monthly data on number of say some other infectious disease, which usually may occur during monsoon season. So, then on the basis of your data, you can verify the claim that the number of patients of that infectious disease increases during rainy season. So, it has some kind of seasonal pattern. During a particular season, the number of patients increases. So, you can take number of influenza patients increases during a particular period, during a particular season. Or annual cancer mortality data of US during 1999 to 2019. Again, this is a time series data. So, the time series data focuses on the same variable over a period of time, while cross sectional data focuses on several variables on several units at the same point of time. So, this is the basic difference between time series data and cross sectional data. And it is very important to identify the correct data type, because ultimately your statistical tools depend upon the type of data which you have collected. Then it is also very important to correct types of data, means it depends upon your objective, what is your objective, for what purpose you want to do the data analysis, or for what kind of inferences you want to draw from your data. Your data type also depends upon your this kind of objectives. So, it is important to collect correct types of data. Then sometimes we also have panel or longitudinal data. Of course, this is not the focus of this course. In this course, I am not going to consider panel or longitudinal data. In panel data, the observations on different cross sections are taken across time. For example, if you take stock returns earned by shareholders of these three companies, Tata Consultancy Services, Infosys and Reliance Industries, at the end of years 2001 to 2020. So, this data set has both kind of informations, time series as well as cross sectional. Similarly, quarterly data on GDP of 8 SAARC countries during 2011 to 2020. Again, your data has both cross sectional information as well as time series information. So, this kind of data is called panel data, or annual cancer mortality data of different Indian states. So, you have different states means different cross sectional unit during 2001 to 2020. So, you have time series observations also. So, this is your panel data. Daily observations on maximum temperature, humidity, wind speed of 13 coastal districts of Tamil Nadu during January to December 2020. Again, this data set is panel data because it has both kind of informations, cross sectional as well as time series. Then what your time series analysis include? This includes the methods for analyzing time series data to extract meaningful characteristics. What are the important characteristics of your time series data? So, we consider different methods for analyzing the time series, so that you are able to extract meaningful characteristics of the data, time series data. Then study the past behavior. So, how the time series is behaving in the past, whether it has some increasing pattern or whether it varies according to some season. So, what kind of behavior it has, how is it behaving? Then identify the pattern of observed time series. So, this is also important, you must identify what kind of pattern time series is following, increasing pattern or decreasing pattern, etc. Then once you identify the pattern, you can use this established pattern to forecast future values. So, identifying such kind of patterns helps you in forecasting future values. Now, here are some applications of the time series. You can apply time series in various fields. Say it can be used for economic forecasting. So, you can use the time series analysis tools for forecasting different economic variables like GDP, the proportion of people living below the poverty line, etc. Then in financial market analysis, it can be used. So, you have past observations, past time series observations on the financial variables, and then you can make use of those past observations or information contained in those past observations for making the forecasts. Then marketing and sales forecasting. So, in sales forecasting it is widely used, and if you can forecast your sales accordingly, you can control your manufacturing process or you can manage your logistics, etc. So, that is why you require sales forecasting. Then census analysis. So, if you are able to forecast the future population, accordingly the government has to manage different resources. Say how many hospitals the government will require after 5 years, or how many houses will be required. So, once you are able to forecast the population after 10 years, after 20 years, then you can, it helps you in managing all such kind of things. Yield projections. So, you can project the yield of next year, yield of say wheat or paddy crop. Then weather forecasting. So, all of you must have seen weather forecast in the newspaper or in the in television news. So, normally they provide weather forecasts for different cities, and sometimes we also plan our visit to some particular place like some hilly place after looking at weather forecast. Then stock market analysis. If you are successfully able to forecast the price of a particular stock, then you can gain a lot of money in the stock market, and if your forecast is poor, then you are going to lose a lot of money in the stock market. Then insurance benefits prediction, or forecasting the number of sales or claims of insurance sector. Then network data analysis. In network data analysis, one can make use of these network uses prediction. How many network users will be there next year. So, accordingly you can plan your or you can manage your network. Then process control for the chemical and process manufacturers, or in signal processing also it is used just to distinguish between signal and noise. So, there are various fields in which we can apply time series analysis. Now, I am giving you the course outline. I am going to cover this course in 40 lectures, 41-hour lectures, and for my lectures, mostly I will use PowerPoint presentation. Of course, at some places for explaining some of the problems or some of the derivations, I will also write and just to explain some of the things. And this is the brief description of different lectures. So, this is the first lecture in which I have introduced or I have given you some basic idea of what is time series, why we need time series analysis. Now, in the different topics of time series analysis, you may require different matrix algebra and regression modeling tools. So, in lecture 2, I have covered some of the main results of matrix algebra, which I may require for other lectures. Although this lecture 2 is not concerned with the time series analysis, in this lecture I will just concentrate on these two topics, matrix algebra and regression models, because these tools are required in other lectures. So, I will also consider the regression model, in which I will consider both the two variable case as well as when you have more than two variables, means multiple regression model. Then I will describe the least square procedure for estimating the parameters of the model, then the concept of R square and adjusted R square for the multiple regression models, or some information criterion also, and then analysis of variance, what is the significance of analysis of variance for the multiple regression model. All those things I am going to cover in lecture 2. In lectures 3 to 6, I will discuss the classical approach of time series analysis, which relies on decomposing the time series into different components like trend component, seasonal component, cyclical component and irregular or random component. These components are decided according to nature of variation in the time series. How the observations are varying, or what is the pattern of variation of the observations. On the basis of that, we decide which of the variation is dominating the movement of the time series, or it may be the combination of all these components which is driving the movement of the time series. So, to understand how the time series is behaving, it becomes very important to decompose the moments of the time series into 4 components. I will also discuss different methods for the determination of, say, trend component or seasonal component or what is the variance of the irregular component. I will also discuss the cyclical component in this in these 3 lectures from 3 to 6. 4 lectures actually from 3 to 6. Then one of the main objective of time series analysis is forecasting. So, one of the popular procedure for forecasting is smoothing and adaptive forecasting. So, in the 7th lecture, I will consider different smoothing procedures and adaptive forecasting procedures for the time series. These exponential smoothing procedures, which I will consider in this particular lecture, may be applied for forecasting purpose when your time series neither has trend component or it does not have seasonal component, or these procedures may be applied when your time series has just trend component, or it has both trend and seasonal component, etc. So, I will discuss all those procedures in 7th lecture. Then in next 3 lectures from 8 to 10, I will move to Box-Jenkins approach. Mainly I will describe the time series processes and different descriptive measures of the time series processes, like how we define mean of the process or variance of the process. Another important measure which plays important role in describing a time series is its autocovariance function or autocorrelation function. So, all those things I will discuss in these lectures. Then these 3 concepts, the concept of stationarity, invertibility and ergodicity, play a very important role in time series analysis. So, the definition of stationarity, why a time series has to be stationary, and what problems one may face if the time series is non-stationary, all those things will be discussed in these lectures. Then the concept of invertibility, why we require a process to be invertible, and another important concept is ergodicity. You can compare this concept of ergodicity with consistency property of an estimator for the classical inference procedures. So, these 3 concepts will also be discussed during these lectures. Then during lectures 11 to 15, we consider different stationary processes for the time series modeling, wall decomposition, general linear process, and different popular processes for modeling a time series are moving average process, autoregressive processes and mixed ARMA models. So, all these 3 processes will be discussed here, their properties, what are the conditions under which these processes are stationary or invertible, or what are the mean function or variances or autocovariances or autocorrelations of these processes, how the autocovariances and autocorrelations behave for these processes. All those things will be considered during these lectures. Then obviously, once you have defined a model for your time series, then you require estimators for the parameters. So, the problem of estimation of parameters of autoregressive, moving average and mixed ARMA processes will be considered in two lectures, lecture 16 and lecture 17. Then in lectures 18 to 22, I will consider the frequency domain analysis of the time series. Actually, for analyzing the time series, there are two approaches. One is time domain, which is based on the autocovariance function or autocorrelation function. Another approach is frequency domain analysis, which is based on spectral density function. So, the details of all these frequency domain procedures will be discussed in lectures from 18 to 22. Then for estimating the spectral density function, we require periodogram analysis. So, that will also be considered in these lectures. Then forecasting is one of the main objectives of time series analysis. So, different forecasting procedures for these stationary processes will be considered in lectures 23 and 24. Then once you fit your model, you require some diagnostic checking or diagnostic tests just to check whether your fitted model satisfies the assumptions on which it is based or not. So, in lecture 25, I will consider different diagnostic checking procedures for stationary processes. Then I will actually move to some more advanced level topics. So, in lectures 26 to 30, I will consider different non-stationary and long memory processes like autoregressive integrated moving average model. And for modeling the long memory, one can use autoregressive fractionally integrated moving average model. Or suppose your time series has seasonality, then one can model the seasonal processes using seasonal autoregressive integrated moving average models. So, all these models I will discuss during these lectures. Then I will also cover unit 2 tests, which are the tests for testing the stationarity of the process. From lectures 31 to 38, I will consider different aspects of multivariate time series processes. Say their frequency domain analysis, then the generalization of ARMA processes for multivariate case, that is vector autoregressive moving average processes, then causality analysis, which is you can say somewhat parallel to regression analysis, then error correction representation and co-integration analysis. So, these are a bit advanced level topics, and I will cover all these topics in lectures 31 to 38. Then sometimes not only the actual observed time series, it is also important for you to model the variability of the process or variance of the process. And for that purpose, one can use ARC and GARC models. So, in lectures 39 and 40, I will cover the different stochastic volatility models, particularly I will cover ARC and GARC processes. The prerequisites for this course are just basic knowledge of probability theory and basic knowledge of statistical inference. Say in statistical inference, you may require some basic idea of least square theory and maximum likelihood estimation procedures, some properties of the estimators like unbiasedness, consistency, minimum variance, etc. Then you will also require some knowledge of matrix algebra, particularly for the lectures from 31 to 38. You will require the background of matrix algebra and multivariate analysis also, because in lectures 31 to 38 I am going to deal with multivariate time series processes. So, definitely I am going to use some matrix algebra results also. Although I have discussed all those results in different lectures, but still if you have some background of matrix algebra and multivariate analysis, then it will be good for you. And I also suggest you to not only just go through these lectures and get some theoretical knowledge of time series, but try to learn some statistical software also, maybe R. I have used mainly R software for solving different numerical problems in the examples. So, it depends upon your convenience, but try to apply all these tools to real data set, real time series data. And once you successfully apply all these tools to real data set, then you get the real flavor of these tools. So, in brief, why we need time series analysis? We need time series analysis just to understand the trends or any systematic patterns present in the data. If your time series data has some kind of pattern, then to understand those patterns, you need time series analysis. You also need time series analysis so that you can get some idea about the probability mechanism which has generated it. So, there must be some probability process, some probability mechanism which is generating your time series. So, you must one of the main objectives may be to get some idea of that probability mechanism, or you can say you want to develop some model for your time series. And once you develop some model for the time series, once you estimate that model, then it fulfills your next objective, that is forecasting the future values. So, on the basis of that fitted model, you can forecast the future values, which is a very crucial, very important objective of the time series analysis. And then you may be interested in drawing more inferences about the probability process which has generated the time series, whether the probability process has some stationary behavior or it has non-stationary behavior, whether it has short memory or it has long memory. If it has long memory, suppose you have a time series which has a long term impact. Long memory means it has long term impact. If there is any change in the time series at the current period, it may have or it may persist for a long time. then you may require to model the time series accordingly, and then using that model you can draw different kind of inferences about the probability mechanism which has generated the time series. So, all these things you can do with the time series analysis. And since nowadays you do not have any problem with the statistical software, and then there are many links from where you can download different time series data in whichever field you are interested, means whether you are interested in time series related with weather, or time series related with air pollution data, water pollution data, or time series related with different economic variables of different countries. You can always find some link from where you can download the data. So, I advise you to download real data set, apply the tools which I am going to cover during other lectures, and then you analyze those real data sets. So, hope you will enjoy this course. So, thank you.
Hello and welcome to this piece of literary snippet. We usually know William Shakespeare as the most revered figure in the history of English literature. But we often tend to forget that he has also been one of the most hated figures in literature. And here I am not talking only about those boys and girls who have to memorize long sections from Macbeth or King Lear or Julius Caesar before they can go and sit for their school or college exams. But I am also talking about people who are themselves quite famous authors. Tolstoy, for instance, considered the writings of Shakespeare to be, and I quote, crude, immoral, vulgar, and senseless. George Bernard Shaw absolutely loathed Shakespeare, as he did Homer. But perhaps no other criticism about Shakespeare is more damaging than the one which says that Shakespeare is a marvelous storyteller, provided someone has told him the story earlier. Now, this piece of criticism is particularly damaging because it is true. None of Shakespeare's plays contain any original story whatsoever. They are all written using pre-existing materials, pre-existing stories. Now, does that diminish the stature of Shakespeare as a dramatist? Well, I'll leave that for you to decide. See you in the next episode of Literary Snippets.